Welcome to lesson 2 of generic protocol in chapter 7. In chapter 1, you've learned how to add constraints to generic functions by using the example of the load class. Likewise, you may also add limitation to protocol extension, so those scope can be only limited to only certain classes and structs. Let's begin. Welcome to Lawrence Suited BOM. Today let's talk about generic protocol, specifically talking about protocol extension and type constraints. Well, limit the scope of protocol extension along with where and self. Well, there are a lot of big words out there. Protocol extension, type constraints. We talked about this in generics. We talked about this in chapter 3 about making your code scalable. But there's a thing. What is a where and self? Well, these are the two big words we're going to take a look at today. And this is how you make your code scalable. Well, let's find out. The first thing, I think it's important for us to review what it means to have type constraints. We talked about it in the last time when working with functions, right? When you make a generic functions, we did something like this. We have a t at low here. So now what's happening, you can only work with, the type of t has to be either low, right? We've done it before, or the subclass of low. So, for example, you can only enter an array whose type is the low, right? That's good. So you're literally having a type constraint to generic protocol, a generic functions. Well, same thing applies to protocol. When you have a protocol extension in the past, in chapter 4, we talked about how you can have a lot of default implementation for a protocol, anything that confirms a protocol, whether classes or struct and enums. But you only want to have that special ability for certain object, certain classes and structs. How to do that? Well, we'll talk about how to use where and self in this case. So first of all, we're going to design a protocol like that, generic protocol with the associate type my type. You can call it Bob type, your type, Sally type, whatever you want it. Okay, and in this case, I'm gonna let some class confirms that generic protocol. So the type is a string for now. All right, you explicitly defined in my type, and I think like this as well. Okay, all good, everything's good, up and running. But now here's the thing. So let's have an extension to generic protocol, and if you have like a static function introduce print, hey, I'm Bob. So now what's happening? Anything that confirms that generic protocol has this introduce print function, hey Bob. That's amazing, right? This is an amazing feature about protocol and programming. You have the amazing ability, to apply to anything that confirms a generic protocol. It just becomes much more scalable. You don't have to apply this function over and over, you know. So now here comes, you can have some structs now has that introduce method, as well as some class has that introduce method. Some struct has that introduce method available right now. But sometimes you're coding, but you don't want every single protocol, and sometimes you want to limit, right? What if you want only some struct to have this function, not some class? Okay, you might have that chance when you're coding. I don't know exactly when would happen in your code base, but that might happen, right? So how to do that? Well, just like generic function we've done in the past here, you can only work with certain types. So this is how you make a little more condition to that. So you can do this. Well, where means nothing more than having conditional statement where my type equals string value. So that means this extension of a generic protocol is only applied if my type, has to whether it's a string value type. So now if you take a look at it, some struct is right now the my type is int, it doesn't have this introduce function available. And of course, some class does have that introduce function available. That's amazing stuff we can work with. That's why protocol and programming is amazing. You'll see where clauses a lot of times because it just allows you to limit some scope, have some scope. Okay, it's important for working with animation. That's a lot of application you can have. But in this course, again, we're talking about the fundamentals. Learn Swift, and next course, learn iOS. Okay, cool. But now there's one more thing. Not only you can have my type, you can also have, let's call it extension generic protocol. You can also have a little more specific, like you can call it self. like this, where you can call it self equals some class. This is very, very specific. Okay, now static function, say something. Okay, okay, I'm some slug. So now what's happening is, what is self in this case? Well, you can already tell, right? Self refers to the blueprint, whether it is struct, classes, or enum, that protocol confirms to. For example, now if you have a class some struct, this is self with a capital letter. Self refers to the blueprint, right? Classes and enums are blueprints, right? That equals some struct. Okay, so now some struct has as my say something, and of course some class does not have that say something method attached to here. So now here comes, you can easily add features with generic protocol. This is amazing, right? If you were to do this kind of stuff within other languages such as JavaScript, Java, it just simply doesn't work. But Swift, on the other hand, allows you to do this kind of amazing stuff, which I'm very happy about. If you do JavaScript, heck no, okay? I'm building a website with JavaScript, and then when I come back to Swift, I'm very amazed what Swift can do for developers like right now, where and self equals, this amazing stuff. Anyway, that is the lesson I will talk about. Just get the fundamentals. You can have extension and also type constraints with what the protocol extension allows you to do. Well, get the fundamentals, and next course let's talk about the application. By the way, I haven't talked about this in the last lesson. You can actually create a predefined associate type. For example, you can have something like this. Okay, associate type, call it family type, doesn't really matter. But now what's happening, you can actually call it int, which is not it doesn't really make sense. But anyway, you can call it for family members, and then this is family type. Okay, and then you can get it set. Okay, here it comes. Of course, it works fine for a family type without having the type available, but you can also have type attached, which doesn't make sense, which goes against what it means to be a protocol, with what it means to have a generic function, generic protocol, right? You don't define the type before you do something, right? Generic doesn't make sense to have type, but in protocol and programming, in Swift at least, they allow you to do that. Okay, so now you can have something like this. Family numbers int 1 to 3. Okay, but let's try this. How about this? Let's try this. Do you think it's gonna override this? String family members, and then let's call this string value, like this. I think it works. I think. Come on. Yeah, it works. Now, what I call it, family type, has become what? String value. So you can override that. Right now, int value when you're first starting out, but you can, when you have a string value, a family that confirms that protocol, you can actually override family type easily. That means you can also type alias, family type, I believe, family type. Oops, you don't have access to it? Oh, that's interesting. Let's try this. Family type. Oh, family type. Okay, I guess you don't really have the access type alias in this case. I didn't know about that. Well, but you can still override that thing right there. But again, this is not good. All right, you don't do this. Right? You don't do that. It goes against what it means to create generic protocol, what it means to create scalable code base. You don't define the type right away. You let the type more fluid, more people can guess it, based on the value. So this is a bad practice. Okay, don't have this int defined. You don't want to do that. All right, you confuse the people. So that's it. We learned how to limit the scope of protocol extension with generic protocol, and using where and self. And by the way, you can have multiple conditions, like you can just start here. If you have something else, self equals some struct, I believe you can also do that. It becomes more specific, okay? But you can also have just one right there. That's it. Hope you guys learned something new with me. If you have any questions regarding how to make this more fun, well, feel free to ask. You can always wait for the next course. Again, I'm emphasizing the next course because so many people are waiting for this, but I just don't have the manpower to record all the time. So I want to get it done as much as I can, but making an ebook as well as making the lecture notes, making source code, it just takes a lot of time, but I'll try my best. And then, yeah, you guys see a lot of good stuff in the future, okay? So see you guys in the later. Like generic constraints, you've learned how to limit the scope of protocol extension by learning about the where clause. What a powerful tool. Subclassing, you may have all these methods and property associated with an object by confirming that protocol. That means you don't need all those unnecessary methods and properties that comes along with subclassing through inheritance. None of that. Do you start to see why protocol or programming provides non-nasty code base? Hope you do by now. It's like this. Come from that protocol, you have the feature. Come from this protocol, you have the feature. Comes from both protocol, you have both features. How amazing is it? How easy is that? In the next lesson, we'll go deeper into how to override associate type. We talked about a little bit in this lesson. Let's go deep in the next lesson. See you.